Hello, everyone. Let's go ahead and work out this example. We're going to find the exact value of cosine of 165 degrees. So first thing you want to do is sketch this. So 165 degrees, we want to determine which quadrant it is in. So we know this is 0, this is 90, we'll have 180 degrees here, 270, and 360 degrees. So as you go around counterclockwise, we have completed one full cycle. So that means 165 degree will lie somewhere in this quadrant between 90 and 180. So let's suppose it's somewhere right here. So let's call this 165 degrees. So we need to find the reference angle. So the reference angle here is this one. So this is going to be the reference angle. So how do we compute that? Well, since we know that this is 180, if I just take away 165, we get the reference. So that's how we're going to do that. So we know the reference angle for 165 would be 180 degree minus 165 degrees. So once you do the subtraction, you'll get 15 degrees. So that's the reference, which means now I can replace this with the reference angle, but we have to be mindful it's in the second quadrant. So on the second quadrant, cosine is negative. How do we know that? Well, hopefully you remember from your pre-calculus class that we memorized this acronym, all student take calculus. So that means S in the second quadrant is positive and it's reciprocal, cosecant positive. Since we're looking at cosine, we're going to have to throw in a negative sign if we use the reference angle. So that's what we're going to do. So we're going to rewrite this. So cosine of 165 degrees is equivalent to negative cosine of its reference angle, which is 15 degrees. And now you go ahead and find the exact value of cosine of 15 degrees, but you multiply by a -1 because of the second quadrant. Now, there are multiple ways to attack this problem. I'm going to go ahead and use the half angle formula in case you haven't seen it yet, how to do half angle formulas. So let's give ourselves a quick recall. So the half angle, let's say you have cosine of some theta over 2. So we're looking at half of an angle. This is equal to plus or minus the square root of 1/2 1 plus cosine of theta. So that's the formula you have to remember if you were to use a half angle to evaluate this. So I'm going to go ahead and show you how to do that using half angle. You could use somewhat different formulas of two angles for cosine. You will get something that looks slightly different from our answer, but eventually it's actually the same value. So let's go ahead and do that. Now, we do need to pick, is it a plus or minus? Now, that will depend on which quadrant this angle lies in. So in our question, we're looking at 15 degrees. So 15 degrees is in the first quadrant. That means we're going to go ahead and pick the positive sign from the half angle formula. So here's how you're going to write this. This is going to be, so let's just put this on the side. This is our recall. So continuing the problem, I'm going to go ahead and apply the half angle formula. But before that, let's rewrite. So we have negative cosine of, so I want to write 15 degrees as some theta over 2 so that I can use this formula so that it is equivalent to 15 degrees. So simply you multiply 15 by 2 and divide it by 2. If I multiply by 2, I'm going to get 30 degrees. And then if I divide by 2, I get 15 degrees. So we don't change the problem. We just rewrite it in a certain way. So now this is our theta from the formula. So hopefully you can see that. So like we said, 15 degrees in the first quadrant. So we pick the positive square root, not the negative, the positive. So this would be negative. The negative was coming from 165 degrees. We got the positive square root of 1/2, 1 plus cosine of theta. Theta is 30 degrees. So that's pretty much how you set it up using the half angle. Now we go ahead and evaluate. So this is equal to negative the square root of 1/2, 1 plus cosine of 30. Now you should have that in memory. Cosine of 30 degree is a square root of 3 over 2. So that's what I substitute for cosine 30. And here we can distribute the 1/2 out to each term and simplify our answer further. This is negative the square root of 1/2 plus square root of 3 over 2 times a half. That's the square root of 3 over 4. And now you want to combine these two into a single fraction, so we need common denominator. So that means we'll multiply this fraction by 2 over 2 to get the 4 in the denominator. So multiply this by 2 over 2. So this will give us the negative square root of 2 plus a square root of 3 over 4. Now here, using by the laws of exponents, I can separate this into two separate radicals. This is negative the square root of 2 plus a square root of 3 over the square root of 4. And then here we can simplify this. That's going to be 2. So our final simplified answer, you can write this as negative square root of 2 plus a square root of 3 over 2. So that will be your final exact value of cosine of 165 degrees. So let's recap quickly. So we first found the reference angle for 165 degrees. So we know that's 15 degrees. So we replace cosine of 165 with cosine 15, but we do need to consider which quadrant 165 is. That's where this negative came from, because it's in the second quadrant. Only sine or cosecant are positive. And then we rewrite 15 degrees as 30 over 2 because we want to use the half angle formula. So then here, using the half angle formula, we chose this square root because our angle 15 degrees in the first quadrant, so we picked the positive square root of that version. This negative, of course, it came from before, so it didn't come from the half angle formula. And then here, just a little bit of algebraic simplification. We got to an answer of negative square root of 2 plus square root of 3 over 2. All right, I hope this makes sense.